Okay, moving on to task 6. So task 6, if you scroll back to task 6 and have a look yourself, you'll see it's talking about that we've got some data for a new projectile, a different projectile. So we've been able to calculate the trajectory for 3 different projectiles. So now imagine another projectile. We don't know the initial angle, the initial velocity, maybe not even the initial height. All we know is that it's the same kind of projectile. So first thing we should do is let's just plot the data. Provided the code for you, all you've got to do is uncomment it, okay? So we'll run the script and we'll just have a look at this data before we do anything else, okay? Might put a semicolon here. Looking at the data like this is not very useful, so we'll put a semicolon here to stop that from printing. But if we open up the plot, we can see what the data looks like. It's a little bit noisy. That's what real world data looks like. You've got an x in meters and a y in meters. So we know the positions in x and y for this projectile. We can look at it here. It kind of looks similar to our previous trajectories, but it's not the same. And we're asked to calculate something about this projectile. We're asked, if you go to scroll, look at task 6, so that I don't want to keep scrolling up and down here because it's a bit weird. It looks bad on the screen. To estimate the tan of theta. So it says, it gives a tip, look at equation 1. So if you go back to equation 1, you'll see that equation 1 says that x and y are related. You've got that they're related like this. Right, so we've done this before. Actually, we've got an easier way to write this formula out, don't we? Let's do it this way. Oops, don't want to cut that, copy. So the nice thing to notice here is that Q1, where we don't know who theta is, you can call it theta 4 if you want. Q1 and Q2, they're just two numbers you don't know. And they relate every x, and then this formula relates every x and y. So this is also something you don't know necessarily. So it says, why don't you check out polyfit? So how is polyfit going to help us? We've got the data that gives us each x and y. How is polyfit going to help us extract something using this equation? So notice that if you can figure out what Q1 is, then you have the tangent of the theta you want. So we need to figure out Q1. So I've opened up MATLAB help. See this is recording properly? Yep. So write polyfit. Here it goes. Let's zoom in a bit more. Polyfit. Polyfit, here's the syntax. Polyfit returns the coefficients for a polynomial p of x of degree n that is a best fit for the data in y. Mouthful. What does that mean? I'm going to do this in 2 videos. First I'm going to show you just how to use this, and I'm going to do another video just about polyfit to explain it in more detail. We've got to think of the left hand side as being y, and it's going to do the fit that best matches y against the formula on the right, where you have to choose how big n is. If you looked in our equation 1, n was 2, so we've just got to choose 2 here. If you scroll down, the examples are often better to understand. So you're given some fake data in x and y. You use a polynomial of degree 7. It means that the y is going to be fit with terms of x up to the power of 7. Okay, and then it gives you some p. So what? This is a bit abstract. What do you do with this p? This next section will maybe help you understand that. So there's 2 things you could do with a p. P is, I think, a vector, where each component of the vector, it says that up here. Yeah, the coefficients in p are in descending power. So the first element of the vector p gives you the coefficient that goes here, the second one here, and so on and so forth. Okay, and this function here just helps you evaluate that polynomial. Right, it's a bit abstract. Let's copy this code. Let's copy this and use it for what we need, okay? We'll take some time to learn this, so don't worry too much. Okay, so we've got some data in x and y. It shows you how to get the x data and y data right here. So we're going to need to put that in here. Y data. We're not going to use this here, this code here. So we're going to comment it out because it can't run at the moment because it doesn't know what theta 4 is. This very first line will give an error. Okay, so we want to fit a polynomial between x and y. So because equation 1 tells us that there's a polynomial, look, this is a polynomial up to degree 2. So we need this to be a 2. And maybe we'll reorder this the same way as it was shown in the documentation of polyfit. And the documentation of polyfit, it called these p's. So instead of q2, let's call that p1. And this one we'll call p2. We're just writing this out to help understand, okay? And is this p3 then? p3 is the last term. So I'm just writing it so it matches the documentation of polyfit. Let's just double check that. So see p1, p2, okay? Just making it easy to understand. So once we run this, what will p be? Let's run it and see what happens. So hopefully the data won't print out anymore because we've got a semicolon. Aha! It's a vector of 3 elements. Okay? Think of that. It's a vector of 3 elements. What do these mean? The documentation describes the first element is the term that you have to multiply here. Actually, it's got no minus in front of it, so we've got to take out this minus here and put that there. So the first element will be this, the value to give to this p1. So that's p, so now you use parenthesis 1, that's the first element. p2 is the value that's here. If you look at it, p2 equals tan of theta 4. So all we need is this value here. That's it. So if we scroll down, that's all we need. So if you remember, I've always told you to think about doing a check to make sure that you've got the right answer. How do we check this is right? We looked at the documentation, we kind of thought about it. Is there anything else we can do? So here, let's try to do something, let's do a check. So what we're going to do is we're going to use on what we think y and x are, how they're related, to do another plot. So first thing I'm going to do is I'm going to generate a bunch of x's using the linspace function. Okay, so how far should I generate the x from? So let's look at the drawing. We could use the formula for d, or you could just go, x goes from 0 up to about 75. Let's just do that, because that's enough for now. So let's make x go from 0 to 75. And you can choose how many elements you want this time. Let's do a column vector as we did before, just because. And then with this, we can generate what we think the y's should be. Maybe we call this x4 to avoid any confusion. So y4 is going to be equal to what? It's this formula here, right? Let's use this formula. And now make sure you put p with a 1 in brackets because it's a vector. Same for the 2, same for the 3. And this is all x3, so this should be x4 now. Same should be up here because we want it to be a new relationship between x and y. We don't want to overwrite the previous one we did. If you were to rewrite what x3 and y3 were here, it would erase what you did before for them. So now what we're going to do is we're going to plot this. We're going to say hold on, and we're going to plot what the polynomial fit says is the relationship between x and y. This dot here made it appear more like a dot scatter plot, so I don't need that now. Okay, let's run the script and see if this is going to work. Might need a dot star there. Ah, look at that. So clearly we've interpreted the way polyfit works correctly because the line it predicts runs right through the middle of that data. So if we've interpreted the way polyfit works correctly, then we definitely have the right number for P2. And we know from equation 1 that P2 is the tan of the theta. So that completes the assignment. So that's all the tasks of the assignment. I'll do an extra video for the extra bit, but for now, I guess we could submit and see what happens. You can only submit once, okay? Be careful to only submit when you're absolutely ready, okay? So this concludes the video on how you do these assignments because we got everything right. I hope you enjoy it. It'll take you a while to get right, but you can go back to these videos. Okay.